All right, so the reason factoring is going to be helpful with polynomials is because it's going to help us find all possible solutions for a polynomial equation. So I added a note over here that you should put on your note packet, and that is the number of solutions is equal to the highest exponent. So in this one, our highest exponent is a 5. So that means in example 6, we should have a total of 5 solutions. So we're going to have 5 answers. If we don't have 5 answers, that means we are missing some of the solutions that would make this equation true or equal to 0. So let's look at this. We're going to solve these by factoring. You're always going to check for your GCF when you factor. This one, our GCF is a 5x. That would leave us with x to the power of 4 minus, and 8, that would be 16 equals 0. Okay. When you are solving for these, another thing that's important is you never divide by a variable. If you divide by a variable, you are going to lose some of your answers for what x could equal or y equals in these problems. So never divide by a variable. I would just recommend leaving it there for now. Okay, after you factor out your GCF, you are going to look for, do you have a difference of squares, difference of cubes, sum of cubes, or do you need to group and then factor? This one we only have 2 terms, so I'm checking for cubes and squares. I know x to the power of 4, that is a perfect square, and then 16 is also a perfect square. So I'm going to factor using difference of squares. And if you need more practice with that, you can go back to the difference of squares video. This one, we're going to split into x squared plus 4, and then an x squared minus 4 equals 0. Okay, now for this problem, we are just solving. So we don't need a completely factored answer. If you were asked to factor, you would need to continue to factor this x squared minus 4. But right now we are just solving. So when you're solving, you want to factor until you get all of the exponents of the variable of 2 or less. So once we get these exponents of 2 or less, because this one has a 1, then you are able to solve from there. You can continue to factor if you want, but you do not have to when we are solving an equation. Once we get to this point and we have all of our exponents of 2 or less, we're going to take each factor individually and set them equal to 0. So if one of these equals 0, the entire equation equals 0. So we have 5x equals 0, x squared plus 4 equals 0, and then an x squared minus 4 equals 0. Then you solve each of these equations individually, and that will give you all of your answers for your polynomial. And this first one, we just divide by 5 on both sides, and we'll get x equals 0. That will happen where you get 0 as an answer. So remember, 0 is a number, it counts. The next one, we have to subtract 4 on both sides. That gives us x squared equals negative 4. Then we're going to take the square root. Remember, when you take the square root while solving an equation, you get 2 answers, a positive and a negative. And when you take the square root of a negative number, we are going to be still using our imaginary solutions. So when we take the square root of a negative 4, it becomes a 2i. Okay. Then our last equation, we're going to add 4 to both sides, and that will leave us with x squared equals 4. Then we take the square root, and that will give us, again, when you take the square root, 2 answers, a positive answer and a negative answer. And the square root of 4 is 2. So we need to check. Did we get 5 solutions? X equals 0 is 1. X equals positive 2 and negative 2i. That gives us our second and our third solution. And then x equals positive 2 would be our fourth. X equals negative 2 would be our fifth. So we have all 5 answers. That shows us we are done with this problem. Okay, the next video we'll go over example 5b.